Okay, so on this one, we need to simplify that expression. How are we going to simplify that expression that they're asking us to do? Simplify that expression. Well, could we just cancel those x squareds and then cancel these x's here? You can tell by my tone the answer is no. Why not? Why can't we just like cancel that stuff right away? It's because we have adding and subtracting, right? Whenever you have adding, let me write the rule up here. So when we have adding, subtracting, we must, let's put it, we have adding, subtracting, we factor. So in other words, what I'm saying is we have to factor. Now this one, the factoring is going to require two parentheses, top and bottom. This is the kind of factoring where you do the two parentheses. You remember that? It's been a little while since we've done this kind of factoring. Well, why didn't I just take out something in common? Because they don't have anything in common. See these top three terms? They don't all have an X, do they? See how this 4 at the back doesn't have an X? So they don't have an X in common. There's not a number they all have. So you have to do the two parentheses. So how do you do that? Remember, it's multiply and multiply. So now as you're looking for two numbers that multiply to be x squared, that'd be x times x in the front, right? And they have to multiply to be 4 at the back. So what's that going to be? Well, what multiplies to be 4 is 1 times 4 or 2 times 2. I'm going to go with the 2 times 2 because I want them to add to be negative 4x. So that means they've got to both be negative, don't they? See how I determined that at the top? Right? Negative 2 and negative 2 add to be negative 4, but multiply to be positive 4. Are you getting really comfortable with those rules? Two negatives multiply to be positive, don't they? But they add to be a bigger negative, right? Because when you add, subtract, it's like weight, gain, and loss, right? If you lose 2 pounds and lose 2 pounds, you lost 4 pounds. But when two negatives multiply, they become positive. So that's right. The top is right. How about the bottom now? Well, same kind of thing. I want to go multiply, add, multiply. So it's going to be x times x in the front. Now, what multiplies to be 6 and adds to be negative 5? Well, what multiplies to be 6? Well, it could be 2 times 3 or 1 times 6. Huh? How do you know which of those you want? Well, you want 2 times 3, both of them negative, because same thing, right? Two negatives multiply to be positive 6. And they add to be negative 5. Like again, if it's weight loss, right? If you lose 2 pounds, lose 3 pounds, you lost 5 pounds, right? So that's the right factorization. Remember all that kind of factoring? And now that we've done all that, we can, oops, here, erase this. Oops. So now we can cancel. So now we can say x minus 2 and x minus 2 just cancel right out. And so we're left with an x minus 2 on the top and an x minus 3 on the bottom. No need for parentheses anymore because there's nothing to separate them from. The other part that was next to them is gone. So we just cancel. So notice I cancel after factoring. Why? Because now they're times. You see what I'm saying? You can cancel times things, multiplied items, but not added, subtracted items. You cannot break the bond. So over here, can I just cancel these x's? No, because they're added, subtracted, or they're both subtracted, right? You cannot cancel an added, subtracted item. So the final answer to this question then is just x minus 2 on the top, x minus 3 on the bottom. They want f of x to be the top, g of x. Hey, by the way, why? If I was you hearing this right now, I'd be going like, why? Why does math make these crazy rules? Why can't you cancel added, subtracted items and only multiplied items? And the answer to that question, why math makes any rule, is because it's true. Let me just prove it real quick. Just think about let's just do adding. What if you had 4 plus 2 over 2? Isn't that really 6 over 2, which is 3, right? 4 plus 2 is 6. 6 divided by 2 is 3. And if you canceled the 2's, now it's 4. See how that's just not right? It's just simply not true. It doesn't work. Whereas, you might be saying, Mr. Aaron, are you saying to me that If that was times on the top, then it would be okay. It's exactly right. If that was times, watch. See how it's actually now true. Now, this is going to be 8 over 2, right? 4 times 2 is 8, which is really 4. See if we cancel the 2's? It's actually correct now, isn't it? You see the deal? It's just simply the truth. Math is just following the truth. You can cancel multiplied items and you'll get the true answer. But if you cancel added items or subtracted items, you'll get a false answer. It's not true. So whenever we see adding, subtracting, that's why we have to factor, meaning make it multiplied, and then we cancel multiplied items, not added, subtracted items. There we go.